Hi again, and it's the next topic, and now we'll talk about fantastic APIs and where to find them. And our next speaker is Roberto. He's Android engineer with a deep love for Kotlin. He's part of Google Developers Expert for Android and Kotlin, and he's working remotely for the New York Times. Um, and he's working on the core application of New York Times. So let me add him. Hello.
Hello, everyone. Thanks for being here.
Yeah. By the way, what is the weather in Italy?
Pretty warm today. I can complain.
Nice. We also have pretty weather in Belarus. Uh, okay. Stage is yours. Rock.
Okay, thanks. Thank you very much. Okay, so let's get started right now with the title, which is one of the most animated slides that I usually make. So let's start from the very basics. That is, what is an API? So API is an acronym that stands for Application Programming Interface. And it is mainly a set of functionality, or actually even better, a contract between one developer and another. Let's give an example. I want you to use my SDK, so I give you my API, which is the list of functions that are available in my SDK and how to use them. So it's, in all cases, a contract between two developers. Of course, it's not a legally binding contract, but when someone breaks it, it's actually kind of boring. So here we have an overview of d.android.com, which is where basically we Android developers spend most of our days. And in this talk, we'll explore some of the API that I recently found that are really, really interesting. So let's start right away with the first example. The first example is related to permissions. Well, I remember when runtime permissions have been introduced a few years ago, they were quite complicated to grasp at the beginning, and definitely the code was, well, not the easiest to remember. Also because you had to actually write it every time you needed the permission. And I mean, do we really need all of that? Well, let's see how they work first. So the first thing that we want to know if we actually already have the permission, especially since latest Android versions, the users can grant or deny permissions at their will. So it's always a good practice to start asking if we have these permissions. The next step is if we should actually request the permission, because there are cases in which the users might have denied the permissions in the first place, so we need to show a rationale that would actually explain the users why we need this permission and what they will be losing if we are not granted this permission. Okay, so we checked if we have the permission and if we should request it, and now we have to make the request. After a while, this request will come back and we should check if we can handle the result. Why is that? Because with the Android API, we will get the result and we will check if there is the right one for us. And only then we will do what we need to do. But usually we don't need only one permission. We need more than that. So we need something that is usually very complicated. And we need to understand which permissions have been granted and which are not granted just yet. So it's not really, really straightforward, especially for less experienced developers. Luckily for us, there is a new feature, which is the activity result contract, that can help us immensely in this case. So what is the activity result contract? Basically, is a contract that we write and that will grant us that the result will be what we expect. So a contract in this case is basically asking another activity to give us a result without all the boilerplate code that we were used to have and to write previously. So the first thing that we need to do in order to use the activity result contract is declaring the dependencies. While they're still in alpha, they are they are more than stable. I mean, you can use them without any fear. I've been using them for months and they work pretty well. Why do we need two of them? Well, we do need two of them because the activity result contract can be used in both activities and fragments. And so we need two smaller dependencies rather than one that will wrap them both. Now, let's see some code about these contracts. Okay, so there are a few important steps here. The first one is the call to register for activity result. The register for activity result is a function inside the app compat activity that will tell the activity that when an activity result arrives, we will be the one managing it, and I will be managing it with the lambda that we pass as second parameter, the one that will check, in this case, if the permissions are what we expect and if they've been granted. The last step is this line here, that is the contract, because the register for activity result actually can take any activity result contract, and what we want to tell to this function is what is the contract that we are using. In this case, the request multiple permissions. So in the lambda, we will have the result of all the permissions that have been granted right there. Okay, so what we need to do is register for an activity result, usually in the onCreate method of our application, our activity, sorry. Then provide the contract that we want to fulfill. And lastly, we want to add the lambda that will be managing the result whenever the permissions are granted in this case. There will be more contracts, but it's important to understand how one of them work, because after all, they all work in a very similar way. The next step is declaring the permissions that we want. So in this case, we declare the access to course location and to find location. Here you can put all the runtime permissions that you want. They don't have to be connected in any way. It's just all the permissions that you need. And if they're granted, they will be shown in the map that we saw in the previous slide. Now, once we have our permissions and the logic to request the permissions, what we need to do is simply launching our contract. And that's basically it. We have three pieces of the puzzle, that is the contract itself, where we explain what we want to do, the permissions that we want, and then we connect them by using the launch function. And whenever the permissions are granted, we get the results back. Of course, there is a way also to create a custom contract that is basically meant to be a class that has two methods. The first one is the one where we define the intent that we want. So that will be fired when we launch the contract, and the parse of the result. that will check the result and return it to our Lambda. As you can see, it's pretty straightforward to create a custom contract for an activity result contract. And it can be used for a variety of reasons. For instance, if you want to open in your beta settings, for instance, the settings page for your app so that you can deny or grant any permissions for any reason, or I don't know, clear the cache or anything, it will be quite easy to create a custom contract in this way. But these are not the only two cases that we have. There are actually many more. One big use case is for getting the content. So we know that we have a specific API for getting content on Android, and with the contracts, it will be even easier to get to the content that we need. Then we have a contract right there for picking a contact. Of course, as we saw, we can request one or more permissions. There will be two different contracts. One will be request multiple permissions, and the other one will be request permission. Two different contracts that will behave in the exact same way. Just they will just change based on the number of permissions that we want to request. Then there are some other contracts, of course, for starting activities for results, or even using intent senders. And of course, there are some contracts for multimedia, like taking a picture, a preview, or a video. So there are a lot of contracts ready out of the box, and we can always create more of them with the functions that we saw. Now, if you're as curious as I am, probably the intent senders thing somehow caught your attention. And this is actually something that I wasn't aware of until very few days ago. So what is an intent sender? It's basically a callback for when your intent is, let's say, it's consumed by another application. Let's see an example. I want to know that my user shared the content, and I want to know on which app this content has been shared. For many reasons. One of them might be for analytics. I want to be sure that when my user shares the content, it's being shared on a messaging app for any reason. The answer to this specific need, since we can't control the dialogue that the user is using, is a system dialogue, it's actually the intent sender. So let's see how it works. First, we need a broadcast receiver, which will be the one that will receive the result from our intent sender. Then we need an intent that will be the one that will wire the receiver, because we need to connect the receiver to our code in some ways. And the last piece will be a pending intent that will be used to create the intent sender. So we have three pieces that need to work closely together in order to get the result. What we want here, again, is understanding what app our user chose when sharing the content from our app. So we're working towards that direction. So, the receiver. The receiver is a normal broadcast receiver that will get an intent in the onReceive function that will be called from the system. And we need to get this component that will be the one that the user chose while sharing the content in one of the extras. Actually, it would be exactly in the extra chosen component. When we check here inside, right after the user shared something on any app, we get the name of the component. That would be, for instance, com.android.whatever app.component. So it will be fairly easy, especially for reporting with analytics, to get what the user chose. But of course, the receiver alone, as we saw, is not enough. We need to create an intent that will be the one wiring up the receiver. But that's a normal use case. So here we want to share some text, as we already mentioned a few minutes ago. So this is the intent that we will create. We have an action send as an action, and we'll put the normal extra to share our text. Of course, this is a standard share intent. But in order to work with the intent sender, we need to wire everything up. So we want to to wire the broadcast receiver, our share component receiver, in an intent so that it can be transformed into a pending intent for broadcast. And from this pending intent, we can get the intent sender. So what these two declarations will do is actually connect the share component receiver, which is our broadcast receiver, with its intent sender. So now they are connected. What happens when we want to actually show the sharing dialog? It's this one. So we want to create a chooser that will show the normal Android sharing screen. And the last parameter, it's the intent sender. What happens now is that when this line is invoked, the dialog will be shown. And when the user will tap on an item, we will get its component in our broadcast receiver right there. Now, let's switch gear to another topic. Many of you will definitely have seen these three lines to check if we have internet or not. So what we do here is checking the connectivity manager for the information about the active network, and then we check if it's connected or connecting, or even just is connected. There is a problem though. Recently, this API has been deprecated. So if you try to use them, you'll get a very reddish warning saying, hey, you cannot use them anymore. And this is scary. So what happens now? Well, we definitely still need the connectivity manager, because that is what will actually check for our connectivity in some other ways rather than what we were using earlier. Then a new object appears, which is the network request. This is an object that will hold the requirements for our network. What are the requirements? Well, the requirements might be the fact that we wanted a Metro network or not, we want internet connectivity or not, we want it to be over Bluetooth protocol for any reasons. These are all the requirements that the network request will be holding for us. The last step is a network callback, because this will be invoked whenever a change in the requested network will appear, whether it is that we are connecting or, well, we are disconnecting from it, because we might want to know both of them. So the first step that we need to take in order to get to these new requests is creating a specifier. How do we do that? Well, there is a new object which is called Wi-Fi network specifier that will host a builder. From there, we will have the possibility to set different data. For instance, there's the network name and the WPA2 password. Once we created the specifier, in this case, we want a specific network that has a specific username and password. We will need to pass it to the network request. And again, well, actually not again, but now we are going in the part that is mandatory. We see why in a few seconds. So the first thing that we want to say in this builder is the fact that we want the transport type to be over Wi-Fi. For example, I didn't want my network to be connected to the internet because I was working on a network that was basically a point-to-point network. Then we can set the network specifier, which will tell our network request that I was looking for a specific network with a specific name and a specific password, and we can build such request. But of the 3 lines that we actually specified here, only the first 2 are mandatory. We don't need the set network specifier in every request, because, well, maybe we just don't need to specify a network that has a specific name. This example was the most complete I could actually came up with, because it was taken from some code that will connect to the network created from a camera. That's why there was also the network specifier. But we mentioned that we not only needed a network request, but we also needed a callback. And the callback is by far, in my opinion, the most interesting part. So in order to create a network callback, we need to create a class that will extend the network callback subclass of the connectivity manager. The 2 more important methods in there will be the onAvailable method and the onUnavailable method. But these are definitely not the only 2. There are many other methods. Among them, there will be, for instance, a method that will be invoked when we are about to lose the network and when we know how much time it's left before we get disconnected from the network. A very important part of these methods is actually the network parameter on the onAvailable method. This will be the parameter that we can use when we need to connect at socket level to a specific network. So in the onAvailable, it's where we will be possibly binding the socket if we ever need to do that. To be honest, it didn't happen to me these many times, probably only once in my life, but this is where I will do if I need to do that again. So now we have the callback that will tell us when our network, the requested network, is available. Then we have the network request that will tell, in this case, the system that you want a network that is over Wi-Fi but not connected to the internet, and it's time to wire them together. And we do them with a method on the connectivity manager that is request network. It will take the network request as a first parameter and the network callback as the last parameter. As soon as the network is found, well, our callback will be invoked and we can remove our callback. If we need to keep on checking this network for any reason, well, we can postpone removing the callback until when we don't need it anymore. Okay, now let's check something that is totally different and it's totally not related to network anymore, and it's fragments. So we know that there is a way to have some callbacks when our activities are created. But what if I want to do the same with fragments? Well, luckily for us, now we can. So now we can basically listen to when fragments change their life cycle. Let's see how we can do that. So the code here is pretty long, but it's not important that it's readable. I will try to guide you through it. So we have this class that extends from the fragment lifecycle callback that has a list of methods. And these 4 are those that you will end up being forced to actually implement. What are them? Well, basically, they will tell you when a fragment is created, when the fragment view is created, because remember, we still have 2 different life cycles on the fragment, which are the view life cycle and the life cycle. Then we will get a notification when the fragment is destroyed and when the fragment view is destroyed. And well, they will be invoked right after these methods are fired on the fragments. But how do we actually get to have these callbacks? Well, it's fairly easy. So we need to create our class, and then we use the support fragment manager to register our fragment lifecycle callbacks, and then register the fragment lifecycle callbacks. But I want to point out something very, very interesting. The second parameter in the register fragment lifecycle callbacks, the true value, is to tell the fragment manager that we want to work in a recursive mode. What does it mean? Well, if we register these lifecycle callbacks inside an activity and we set the recursive mode to true, we'll tell the support fragment manager that if any of our fragments will ever spawn a child fragment, well, we want to be informed. And since this is set to true, if a child of one of our child fragments is created, well, we'll be notified as well. So why do we need this API? Most of the times, you might want them for debugging purposes. It happened to me in many times that there were problems with fragments, and it was complicated to understand how they were being generated. With these listeners, it was, well, not easy, but easier to understand what was going on and how we could understand the fragment lifecycle better. Okay, to another topic now, something that is, well, let's say new to Android, but it's not really new, and is how we can authenticate our users. And by authenticate, what I mean here is basically when an app asks you for your fingerprint or your face if you are on one of the last biometric device that are on your phone, iPhone Pixel 4, for instance. Well, this isn't the easiest piece of API that I've ever encountered, but it's not an easy problem to solve. So let's dive into this and understand how this works. So the first thing that we want to do is checking if we actually can use biometric hardware. Because while probably as developers we have high-end devices, it's not said that all of our users actually will be on higher-end devices. And probably less expensive phones would have less sensors. And probably we can't even use this kind of authentication. Once we understood that we can actually use biometric hardware, we want to create the info for our UI. That is what our users will see right there. Then we need a way to manage the callbacks for authentication. Because of course, this is a process that is asynchronous and we need callbacks. Then another step would be to create the prompt to actually connect the callbacks. And after all these steps, we can finally authenticate our users. Again, this is an external library, so we need some dependencies. This time, it is in a stable release. So, well, it's actually not one of the newest libraries in the Android X package. So, that's good. The first problem that you wanted to solve was if we can use the biometric hardware. So, the first thing that we need to do actually, is taking the biometric manager from a context and then check the result of the can authenticate call. Basically, the only one that we want to be in is the biometric success. Otherwise, well, we can actually instruct our user in some cases, but well, there will be basically two error states. That is that we have no hardware or that we cannot reach the hardware. So the hardware is there, but it's unavailable for many reasons. Probably the device is enrolled in the device management system, and the authentication is only granted through passwords. The last step, the last value, is the one that we can instruct our users the more. That is when there is no authentication registered to the device. So the user never registered their fingerprint and they never registered their face. So basically, they have to do that if we want them to use the biometric authentication in our app. The next step will be to build the prompt informations. And we do that with the builder. This is what the users will see right there. And well, we can basically only set very few things. That is the title, the subtitle, and the description. And the important part is that we can set a negative button or the possibility to log in using credentials. So either we use the negative button to cancel the authentication, or we tell the user that they can use some other credentials. They cannot go basically in the same way. Otherwise, the last invoked will be the one that we will see in the UI. Once we set all the data that we want, we can build this prompt info, and we will use that later. As we talked about a few minutes ago, we need, again, a callback. And our callback here has, well, three states. The one that we expect will be the succeeded, where we have the result of our authentications. But we also have, two states in which actually our authentication went wrong. One will be when we fail the authentication, and one when there is an error. Usually, you fail the authentication when the user is not authenticated, and the authentication error is when there is some other system failure. And that's why we also have an error code, an error string. Once we also have the callbacks, we connect everything together in a biometric prompt. As you can notice, here we have an executor. Well, an executor is because we might want to run this code somewhere else. I don't really know why it has been decided to pass an executor as one of the parameters. But usually what I do here is pass the equivalent of the main thread. Because when I create this object, I want it to be right there, and it's usually not blocking anything. The other parameters are the activity where we want to use the context, and the callback. So we created our biometric prompt, the prompt info, that is our UI, and the callback. And now we can authenticate our users with a single line of code, which is this one. So we will use the biometric prompt to authenticate by using the prompt info that we created. One thing to remember is that our prompt info can be tweaked a little bit through flags and with some function invocations that will be, for instance, those to show the cancel button rather than the use of other credentials, or even if we want the bigger or the smaller UI, or if we want that upon recognition of the user, we simply get through. So if you ever saw this prompt, basically it will change that when the system will recognize you, you will have to press OK, or it will just go through on its own. This can all be tweaked in the prompt info, but there is not much more that we can do. So I think that we are finished with the slides, and I think that we have a bit of time for any question that you might have.
Yeah, thank you. It was a nice presentation. So guys, you have a time to ask your questions. We're waiting. By the way, I have one question from my side. Your talk called Fantastic APIs and where to find them. So where did you find them? Do you have some source of information?
Well, mostly out of luck. So for instance, the intent sender was, while I was reading the documentation for the activity contracts, I found this intent sender. Mm-hmm. And I was curious because I never used them. And so I explored them a little bit and tried them a little bit. And yeah, it was nice. And so I talked about it. For what concerns instead the network stuff, well, basically, in some of the latest versions of Android, the network management changed a little bit. Mm-hmm. So we found in a situation where we wanted to change our UI based on the fact that the user was offline or not. So I tried to use the old method. We had a subject that was emitting the result of the is connected or connecting, but it was incredibly imprecise. So I found this new way of querying the system, and even if it's sometimes late, based on, well, it's not synchronized with what you will see in your system. Like for instance, you request for a Wi-Fi, and you might get the callback a few seconds after you get connection, or even a few seconds before you see the Wi-Fi icon on your phone, but it's actually incredibly stable and it can give you a lot of information. There were also some other APIs that I wanted to explore, but they were probably much more complicated to set up for a sample project. And I wanted to talk about API that I tried firsthand. So,
Mm-hmm.
for instance, everything that is connected to the Play service that would request me to publish an app to the Play Store just to test them, I had to exclude them. Probably in the future, but
Yep. Okay. We have another question. So, which API you are missing as a developer? It's a nice one.
um, probably. Um, well, I don't know if there are APIs like that on other platforms, but definitely Bluetooth API, like higher level Bluetooth API. I don't
Mm-hmm.
want to mess with bytes. I mean, no, I prefer something more higher level and definitely something also for network management. For instance, I was talking about the example of the camera. One of the problems that you face with cameras is the fact that you don't have internet and our phones are instructed to use internet as primary source. So there isn't an easy way to disable the captive portal detection or to actually tell your app, I'm saying just your app, to use a specific Wi-Fi. There are some
Mm-hmm.
flags that you can run from ADB, but I wouldn't ask a user to say, hey, connect your phone to your computer and run this script and magically it will work. So probably something along those lines are definitely two APIs that I miss.
Mm-hmm. Um, Next question. What about keyboard APIs? Is there any new things in it?
Um, I don't know if there is any new things for keyboard APIs. I know that Google is working pretty hard on their keyboard, on the Google keyboard, to give it even more features. But to be honest, I never tried the keyboard APIs. It's something that always scared me a little bit. So, something that I probably will check in the future, though.
Yeah, I also didn't have a chance to try it, but okay, we don't have more questions. So, Roberta, you can opt for the best one.
Ah, I really liked the first one, the
Yeah,
one about the missing API.
Misen, yeah, I also like this question. So, Alexander, you're our winner. Congrats you. Uh,
Congratulations.
yep. Uh, and as we don't have more questions, I want to say thank you again for the nice presentation. And tomorrow is a beautiful day, and you know why? Because tomorrow is a Flutter day.
Oh,
Yeah, whole day will be dedicated to the Flutter, and I do love Flutter. I have a pet project on the Flutter, and uh, I think that some approaches are quite similar with Jetpack Compose, and I tried it for some small applications. Yeah, and also don't miss the exclusive episode of the Mobile People Talks podcast. It will be in live, and as far as I know, Roberto will be one of the guests, so you'll meet him.
yeah.
Yep.
Thanks for having me. And well, enjoy your Flutter Day tomorrow. And well, thank you for having me.
Yeah. Thank you, guys. Bye.
Bye.